National Electrical Code, specifically Section 680.11 in both the 1999 and 2002 editions, addresses the location requirements for motors driving pumps associated with swimming pools. This section is crucial for ensuring electrical safety and preventing hazards related to the proximity of electrical equipment to water. Section 680.11 states that a motor driving a pump, such as those used for circulating, creating jets, or making waves, when located outdoors, must be positioned no less than 5 feet, which is equivalent to 1.52 meters, from the inside walls of the pool. This requirement is consistent across both the 1999 and 2002 NEC editions. The primary reason for this distance requirement is to minimize the risk of electrical shock. Swimming pools and their surrounding areas are inherently wet environments. Water can easily come into contact with electrical equipment, creating a pathway for electrical current to flow through the water and potentially through individuals in or around the pool. By maintaining a minimum distance of 5 feet between the pool's inside walls and the pump motor, the likelihood of accidental contact with electrical components is significantly reduced. This separation provides a buffer zone, making it less likely that water splashed from the pool or moisture from the surrounding environment will reach the motor and cause a short circuit or other electrical fault. Furthermore, the 5-foot distance requirement also helps to prevent the pump motor from being easily accessible to individuals in the pool. This is important because even if the motor is properly grounded and insulated, there is always a potential risk of electrical leakage or equipment malfunction. By keeping the motor at a distance, the risk of someone accidentally touching a live electrical component while in the pool is minimized. It is important to note that this requirement specifically applies to motors located outdoors. If the pump motor is installed indoors, such as in a pump house or equipment room, different rules may apply. The NEC provides separate guidelines for indoor electrical installations in wet or damp locations, and these guidelines should be followed accordingly. When installing a pool pump motor, it is crucial to carefully measure the distance from the inside walls of the pool to the motor's location. This measurement should be taken from the closest point of the motor to the closest point of the pool wall. It is also important to consider the surrounding environment and any potential obstacles that may affect the safety of the installation. For example, if there are trees or other vegetation near the pool, they should be trimmed to prevent branches from falling onto the motor or interfering with its operation. In addition to the distance requirement, there are other important electrical safety considerations to keep in mind when installing a pool pump motor. Firstly, the motor must be properly grounded to provide a safe path for electrical current to flow in the event of a fault. Grounding helps to prevent the motor from becoming energized and posing a shock hazard. The grounding system should be installed in accordance with the NEC and should be regularly inspected to ensure its effectiveness. Secondly, the motor should be protected by a ground fault circuit interrupter, or GFCI. A GFCI is a device that monitors the flow of electrical current and can quickly shut off the power if it detects a ground fault. This can help to prevent electrical shocks and other injuries. The NEC requires that all electrical outlets and equipment near swimming pools be protected by GFCIs. Thirdly, all electrical wiring and connections should be properly insulated and protected from moisture. This is especially important in wet environments like swimming pool areas. Wires should be run in conduit or other protective enclosures, and connections should be made using waterproof connectors. Fourthly, it is important to use the correct size and type of wiring for the motor's electrical requirements. The wiring should be able to handle the motor's current draw without overheating or causing a voltage drop. The NEC provides tables and guidelines for determining the appropriate wire size for different applications. Fifthly, the motor should be installed in a location that is easily accessible for maintenance and repairs. This will make it easier to inspect the motor, lubricate its bearings, and replace any worn or damaged parts. The motor should also be protected from the elements such as rain, snow, and direct sunlight. Sixthly, it is important to follow all of the manufacturer's instructions for installing and operating the motor. The manufacturer's instructions will provide specific information about the motor's electrical requirements, installation procedures, and safety precautions. In addition to the NEC and the manufacturer's instructions, it is also important to consult with a qualified electrician to ensure that the pool pump motor is installed safely and in accordance with all applicable codes and regulations. A qualified electrician will have the knowledge and experience to properly assess the electrical system and identify any potential hazards. They can also help to ensure that the installation meets all of the requirements of the NEC and local building codes. It is important to remember that electrical work can be dangerous, and it should only be performed by qualified individuals. Attempting to install a pool pump motor without the proper training and experience can result in serious injury or even death. Section 680 of the NEC covers electrical safety requirements for swimming pools, spas, hot tubs, and other similar installations. This section provides detailed guidelines for grounding, bonding, wiring methods, and equipment location. It is essential to carefully review and understand all of the requirements of Section 680 before installing any electrical equipment near a swimming pool. Some other key considerations from NEC 680 include firstly, bonding, which refers to the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed. Bonding reduces the voltage gradient in the pool area, minimizing the risk of electric shock. Secondly, equipotential bonding, which is required to create an area of uniform electrical potential around the pool. This involves bonding all metallic parts within a certain distance of the pool, such as ladders, handrails, and diving boards. Thirdly, wiring methods, including the types of wiring and conduit that are permitted for use in swimming pool areas. The NEC specifies requirements for burying cables, protecting conductors from physical damage, and preventing water from entering electrical enclosures. Fourthly, GFCI protection. As already mentioned, GFCIs are required for most electrical circuits and equipment located near swimming pools. GFCIs are designed to detect ground faults and quickly interrupt the power supply, preventing an electric shock. Fifthly, underwater lighting, which must meet specific requirements for installation, grounding, and GFCI protection. Underwater lights must be listed for swimming pool use and installed in accordance with the manufacturer's instructions. Sixthly, overhead conductor clearances, because the NEC specifies minimum clearances for overhead power lines above swimming pools and surrounding areas. These clearances are designed to prevent accidental contact with power lines. Furthermore, when dealing with pool pump motors, it's important to understand the various types of motors that are commonly used. Induction motors are a popular choice for pool pumps due to their reliability and efficiency. These motors operate on the principle of electromagnetic induction and are available in a range of horsepower ratings to suit different pool sizes and pump requirements. Variable frequency drivers, or VFD, are sometimes used to control the speed of pool pump motors. The VFD allow the motor to run at different speeds depending on the demand, which can save energy and reduce noise. However, VFD must be properly installed and grounded to prevent electrical interference and ensure safe operation. Furthermore, when selecting a pool pump motor, it is important to consider its energy efficiency. Energy-efficient motors can save money on electricity bills and reduce the environmental impact of pool operation. Look for motors that are labeled with the Energy Star rating. This mark indicates that the motor meets certain energy efficiency standards. Regular maintenance is essential for keeping a pool pump motor in good working condition. This includes lubricating the bearings, cleaning the motor housing, and inspecting the wiring and connections. It is also important to protect the motor from the elements such as rain, snow, and direct sunlight. A pool pump motor cover can help to extend the life of the motor and prevent damage. If the motor is not running properly, it is important to troubleshoot the problem and make any necessary repairs. Common problems with pool pump motors include overheating, bearing failure, and electrical faults. If you are not comfortable working on electrical equipment, it is best to consult with a qualified electrician. In summary, the 5-foot distance requirement for pool pump motors, as outlined in Section 680.11 of the 1999 and 2002 NEC, is a critical safety measure designed to minimize the risk of electrical shock. By understanding and adhering to this requirement, as well as other relevant electrical safety guidelines, you can help to ensure a safe and enjoyable swimming pool environment. Always consult the latest edition of the NEC and local building codes for the most up-to-date requirements, and consult with a qualified electrician for any electrical work related to swimming pools. Always prioritize safety when dealing with electricity and water.